This tutorial provides an overview of the visualization tools that are available in NeuroDOT. In general, there are two broad applications. First, the visualization tools can be used to view the tomographic map that is generated by the NeuroDOT processing pipeline. This example shows activation in visual cortex during presentation of a visual grating, reconstructed from optical data using NeuroDOT and rendered onto the cortical surface. The visualization tools can also be used to render other types of data, such as statistical parametric maps generated using modeling functionality in NeuroDOT or other imaging software. The example shown here is a contrast map that was created by saving the NeuroDOT reconstruction as a Nifty file, importing the data into SPM, performing a statistical analysis, then displaying the results using NeuroDOT. In general, the visualization tools fall into four categories, depending on whether they render images on sections or on the cortical surface, and whether the tool is interactive or used in a script. For scripted visualization, NeuroDOT provides the functions plot slices and plot interp surf mesh, which generate sectional or surface renders. The Render Tool app provides interactive access to the surface rendering functionality. Scripted access is implemented identically in the MATLAB and Python versions of NeuroDOT, the API having the same function name and calling convention. Currently, interactive surface rendering is only available in the MATLAB version. Porting this functionality to Python, as well as offering interactive access to sectional rendering, is planned for a future release. In this tutorial, we summarize the plot slices and plot interp surf mesh functions. Use of the Render Tool app is described in a separate tutorial. For brevity, the example shown here will demonstrate the MATLAB version of the functions. The Python implementation is functionally identical. Plot slices is used to superimpose an overlay on an underlay in sagittal, coronal, and transverse views. The underlay is typically an anatomical atlas, and the overlay is functional data. We pass the underlay data, underlay information such as the orientation and origin, display options, and lastly, the overlay data. Optionally, fewer parameters can be passed and default values are applied. We can plot only an underlay by omitting the overlay parameter, use default display options by omitting the options parameter, and use default underlay features by omitting the underlay info parameter. The underlay used with plot slices is typically a standard anatomical atlas. A collection is included with the NeuroDOT distribution as shown here. These include segmented and unsegmented M and I atlases in Nifty and 4DFP format. As a first demonstration, we load an underlay and plot it. The underlay is a segmented image based on the MNI 152 atlas, included in the NeuroDOT distribution as a Nifty file. The data is input using the NeuroDOT function, load volumetric data, which will be described later in the tutorial. Once input, the data is then passed to plot slices. A new figure is opened and sagittal, coronal, and transverse views of the atlas are shown. Clicking in any of the views dynamically changes the display plane. Note the figure menus are functional and can be used to scale and annotate the contents, as well as print or save the figure in a variety of graphics file formats. Terminate viewing by pressing the Q or Escape key or the middle button on a 3-button mouse. Then close the window using the Close button at upper left. Next, we demonstrate the most common application of plot slices, using the function to superimpose functional data on an anatomical underlay. First, we load an atlas that matches the resolution of the functional data. This is a requirement when using plot slices. Next, we load the overlay. We then pass the underlay and overlay to plot slices. In this example, empty arrays are passed for the other parameters so that default settings will be used. A new figure window is opened, and sagittal, coronal, and transverse views of the atlas are shown with the functional data superimposed as the colored areas. We can explore regions of interest by clicking through the sections. As before, terminate viewing by pressing the Q or Escape key or the middle button on a 3-button mouse, then close the window using the Close button. In these demonstrations, the underlay and overlay were input using the NeuroDOT function, load volumetric data. The function can read files in either Nifty or 4DFP format. If the file is located on the MATLAB search path, only the file name is required. An alternate syntax is available in which the file name, path, and extension are provided separately, which can be used to load files that are not in the MATLAB path. Additionally, the function will return file information if called with a second output parameter. This may be familiar if you have worked with nifty files, which are organized as data and a separate header that contains image information such as the volume dimensions, spatial transform, and data type. A common use of the info structure is to check the compatibility of the overlay and underlay. If the resolution of these files does not match, plot slices returns an error as shown here. We can investigate by examining the info structure of both files. If necessary, it is possible to change the resolution of one of the images. The NeuroDOT function affine 3D IMG implements this operation. However, in the demonstration, and in general, the preferred solution is to simply select an underlay that is compatible with the overlay if possible. Finally, plot slices can be customized by passing an option structure as the third parameter. This allows you to customize the scaling, color map, and other display features. Details are provided in additional resources listed later. The second visualization tool provided by NeuroDOT allows you to render functional data on a cortical surface. Use of plot interp surf mesh is conceptually similar to plot slices, but the underlay is a three-dimensional cortical mesh. A collection of cortical meshes is included with the NeuroDOT distribution. The files differ in mesh resolution and whether multiple meshes are defined, for example, based on increasing the amount of cortical inflation. A simple demonstration is shown here. In the MATLAB version of NeuroDOT, the cortical meshes are provided as mat files, and the mesh of interest is loaded using the MATLAB load command. The overlay is input using load volumetric data as before. Finally, plot interp surf mesh is called. In this example, we omit the final parameter so that default display options are used. A new window is opened displaying the overlay rendered on the cortical mesh. As with plot slices, the window menus are functional and can be used to scale, rotate, annotate, and save the figure. Close the window using the Close button at upper left. As a second demonstration, we render using an inflated version of the cortical mesh. This is done by setting the appropriate field of the parameter structure and passing this variable when calling plot interp surf mesh. Note to use inflation, the selected cortical mesh file must include an inflated view. You can check this by examining the mesh structures for the fields inodes and vinodes, which specify the geometry of the inflated and very inflated cortex respectively. Other customizable plot interp surf mesh parameters include view selection, scaling, color map, and display of a color bar. Usage information for all of the functions presented here is available using the MATLAB help command. Note some of the parameters used by plot interp surf mesh are described in the helper function plot LR meshes. As a next step, you may wish to work through the PowerPoint tutorial that provides self-guided instruction in use of the functions introduced here. A separate video tutorial is available that describes use of the NeuroDOT render tool for interactive visualization. Additional information may be found in the resources listed here. Feel free to contact the development team with questions or post them in the comment section below. Thank you for your interest in NeuroDOT.